In 2007, the Environmental Protection Agency handed the American trucking industry a deadline that felt more like a death sentence. By 2010, every diesel engine built in the country would have to cut its nitrogen oxide emissions from 2.4 grams down to just 0.2. That is a 92% reduction, demanded in under 3 years. For every engine maker in America, it was the hardest problem of a generation. And there were only 2 ways through it. Almost everyone chose the safe road: Cummins, Detroit diesel. The giants of the industry all agreed to add a second system that would scrub the exhaust after it left the engine. It was complicated, it was expensive, but it worked. Then there was America's truck giant, Navistar. The company behind the International brand, a name that had hauled this nation's freight for more than 100 years. Navistar looked at the safe road and refused to take it. Its leaders were convinced they had found something better, something simpler, something they believed in so completely that they bet the entire company on it, while publicly mocking every rival who disagreed. They called it advanced exhaust gas recirculation. They called it elegant engineering. And they were about to discover what happens when confidence runs ahead of physics. Because the engine built to save Navistar would instead cripple it. It would strand thousands of trucks on the shoulder of the highway. It would trigger lawsuits, federal penalties, a collapsing stock price, and a fraud investigation that reached the very top of the company. Within 6 years, the engine would be dead, a Texas factory would go dark, and 900 workers would lose their jobs. This is the story of the fatal MaxxForce factory. How one arrogant bet on a single engine broke one of the oldest names in American trucking. It is not just a story about diesel and deadlines. It is about the fatal cost of refusing to admit that you are wrong. Stick around, because this is a slow-motion disaster you have to see to believe. To feel the weight of what was about to be lost, you have to know the name: International. It began more than a century ago, when Cyrus McCormick's Reaper Company and its rivals merged into International Harvester, a titan that put tractors on American farms and trucks on American roads. For generations, the International badge meant something simple and solid. It meant a machine built to work and to keep working. By the 2000s, the truck and engine business had become Navistar, but the heritage still ran underneath it. This was not some fly-by-night startup. This was one of the oldest industrial names in the country, a company that had helped mechanize a nation, which is exactly what makes the choice it was about to make so hard to understand. Giants are not supposed to gamble everything on a single roll of the dice, but this one did. To understand how it all went wrong, you have to understand the trap that every diesel builder was standing in. Nitrogen oxides form when diesel burns hot. The hotter and more efficient the combustion, the more of this pollutant an engine produces. So the government was asking for something that sounded almost impossible: cleaner air without sacrificing the power, the fuel economy, and the durability that truckers depended on to earn a living. An engine that ran cooler, yet somehow pulled just as hard. The rest of the industry settled on one answer: selective catalytic reduction. The idea was to let the engine burn the way it always had, then treat the dirty exhaust downstream after it exited the cylinders. A separate tank would carry a urea solution called diesel exhaust fluid. The system sprayed a fine mist of that fluid into the exhaust, where a catalyst converted the nitrogen oxides into harmless nitrogen and water. Cummins ran the numbers and committed. Detroit Diesel followed, pouring money into the same technology and partnering with suppliers like Bosch to perfect the injection hardware. It meant a 20-gallon tank, electronic dosing controls, and drivers who would have to refill the fluid on a schedule. It added weight. It added cost. It added one more thing to maintain. Even Caterpillar wrestled with it. For a time, Cat leaned toward the harder path, the same one Navistar would choose. But when Cat's engineers looked hard at the numbers, they saw a wall they did not believe they could climb. Rather than gamble, Caterpillar walked away from the North American highway engine business altogether in 2009. A titan of American machinery simply folded its hand and left the table. That decision should have been a warning to everyone still playing. To Navistar, it looked like an opening, because Navistar's engineers believed they had seen something the others had missed. Why bolt an entire second system onto the back of a truck, they asked, when you could solve the problem inside the engine itself? Why carry a tank of fluid to clean up a mess you could simply avoid making? It was a seductive question. It had the ring of common sense. And common sense in the hands of confident men can be the most dangerous thing of all. The technology Navistar chose was called Advanced Exhaust Gas Recirculation. Recirculation was not new. Diesel engines had used it since the 1970s. The concept is simple enough. You take a portion of the spent exhaust gas and route it back into the cylinders. That inert gas crowds out oxygen and lowers the peak temperature of combustion, and cooler combustion means fewer nitrogen oxides formed at the source. Traditional systems recirculated a modest share of the exhaust, somewhere in the range of 5 to 15%. It was a gentle nudge. What Navistar proposed was not a nudge. It was a shove. To hit the new standard without any exhaust treatment, their system would have to recirculate a massive amount of exhaust, in the range of 35 to 40%. To force that much hot gas back through the engine meant redesigning the air handling, the cooling, and the entire combustion strategy from the ground up. The marketing, though, was beautiful in its simplicity. No fluid, no urea tank, no extra refills, no new maintenance headaches for the fleet owner. Just a cleaner burning engine that met the law on its own, while the competition strapped on tanks and pumps and plumbing. At the center of it stood the chief executive, a man named Daniel Eustian. He became the public face of the gamble, appearing at industry conferences to praise what he called elegant engineering. He did not merely defend the approach. He mocked the alternative. He predicted that rivals would eventually abandon their complicated systems once fleets grew tired of buying fluid, and that they would come crawling toward Navistar's simpler idea. The company printed side-by-side comparisons, the clean little MaxxForce on one side, the competitor buried under after-treatment hardware on the other. It was a bold story. It was a confident story. It was, in the end, a story the physics would refuse to honor. Remember that word, elegant. Navistar was about to learn that there is nothing elegant about pumping the fire of an engine back into itself. And here is the part that would come back to haunt them. This was not a slow, cautious rollout hedged against failure. Eustian and his leadership bet the whole enterprise. There was no serious backup plan running in parallel, no quiet second engine waiting in the wings. If advanced recirculation failed, there was nothing to fall back on. They had not just picked a road. They had burned the map to every other one. It is easy, years later, to call it foolish, but sit in that boardroom for a moment. The prize was enormous. Win, and Navistar would own the simplest, cheapest, cleanest engine in the industry, while every rival stayed stuck lugging tanks of fluid. The upside was a kind of monopoly on common sense. That is the seduction of a big bet. It shows you the reward in high definition and the risk in fog. There was one more thing Navistar chose not to talk about. They had walked this road before, and it had already ended in disaster. For years, Navistar had built the diesel engines that powered Ford's heavy pickup trucks. The famous Power Stroke line, the 6.0-liter version, and the 6.4-liter that followed, were supposed to be workhorses. Instead, they became infamous. Owners battled failures, repair bills piled up. Trust eroded on both sides. The relationship curdled into open warfare. In 2007, the same year the new emissions clock started ticking, Ford sued Navistar over engine pricing and the cost of fixing the troubled engines. Navistar at one point halted shipments and threw Ford's own production into chaos. By early 2009, the two companies reached a settlement to end their partnership. and Ford made a decision that should have frightened anyone paying attention in the halls of Navistar. Ford walked away entirely and built its next power stroke, the 6.7-liter, in-house. One of Navistar's biggest customers had just looked at the company's engineering and decided it would rather do the work itself than trust them again. Here was a giant that had already lost a marquee partner to reliability problems, standing at the edge of an even bigger bet on even harder technology with even less room for error. The warning could not have been louder, and no one at the top seemed to be listening. So Navistar went to work. And to see what they were really up against, you have to walk onto the factory floor. Picture the development campus, where the company concentrated its advanced recirculation program. By many accounts, roughly 200 engineers worked there around the clock, chasing a system that pushed the limits of what recirculation had ever been asked to do. This was the heart of the operation. This was the factory that had to make the impossible run. These were not paper pushers. They were some of the best diesel minds in the country, working nights and weekends, believing they were on the edge of something historic. In a sense, they were, just not the history they imagined. Walk the floor and you would have seen it everywhere. Test cells running engines through punishing heat cycles, coolers pulled apart and studied for the telltale cracks. Whiteboards full of temperatures that no intake was ever meant to survive. The people here were not lazy or careless. They were being asked to repeal the laws of heat on a deadline because someone above them had already promised the world it was done. The MaxxForce family spanned a range of sizes, from mid-range engines up to the heavy hitters, all sharing the same aggressive recirculation architecture. The flagship was the MaxxForce 13, a 12.4-liter heavy-duty engine, rated up to 475 horsepower and around 1,700 pound-feet of torque. It is worth knowing where that engine came from. Its basic architecture was developed with the German engineering firm MAN, a respected name in diesel. The larger MaxxForce 15 was built on the block of a Caterpillar C15, with Navistar's own fuel and emissions systems layered on top. These were not crude engines. The bones were serious. The problem was never the bones. The problem was the heat. Think about what advanced recirculation actually demands. You are taking exhaust gas that leaves the cylinders at temperatures well over 1,000 degrees Fahrenheit, and you are shoving nearly 40% of it back into an engine that was designed to breathe cool, fresh air. Before that scorching gas can re-enter the intake, it has to be cooled down to a few hundred degrees. The part that does that cooling is called the recirculation cooler, and on the MaxxForce it became the single most critical and most tortured component in the entire machine. Imagine the job it was given. A cooling system originally meant to hold an engine at a safe operating temperature was now asked to absorb heat loads that belonged in a furnace. Every time the engine warmed up and cooled down, the metal inside these coolers expanded and contracted, over and over, cycle after cycle. Superheated gas on one side, engine coolant on the other, a thin wall of metal in between, flexing under thermal stress that never really stopped. On paper, in a lab, for a while it could be made to work. Navistar poured hundreds of millions of dollars into making it work. Engineers redesigned, recalibrated, and tested. But an engine does not live in a lab. It lives on a mountain grade in July and in a blizzard in January, hauling 80,000 pounds for a driver who cannot afford to stop. And out there, in the real world, the elegant idea began to come apart. Literally. You could not see the flaw in a brochure. You could not hear it in a conference speech. It lived deep inside the engine, in the seams and joints where extreme heat met cold metal. And it was patient. A MaxxForce could run fine for tens of thousands of miles, long enough to earn a fleet's trust, long enough to sell the next order. Then, without warning, the trap that had been building all along would finally spring. The first domino was the recirculation cooler. Subjected to that relentless thermal cycling, the coolers began to crack. Fractures opened at the joints and inside the core, and even stainless steel struggled against the endless expansion and contraction. When one of these coolers failed, there was no mistaking it. Engine coolant leaked into the exhaust, and the tailpipe erupted in a towering white cloud of steam, as if the truck had suddenly become a steam locomotive under full load. Worse, exhaust could force its way back into the cooling system and drive the pressure past its limits, blowing coolant out of the tank and popping the radiator cap. Then the next domino fell, the turbocharger. MaxxForce engines used a variable geometry turbo, a precise electronically controlled device that had to manage those enormous recirculation flows. It was a fine instrument asked to work in a filthy, brutal environment. The recirculated exhaust was thick with soot, and that soot began to cake onto the moving parts. The carbon built up like cement, locking the turbo's delicate mechanism in place. As boost control slipped away, the engine's computer would dump in more fuel to compensate, which drove temperatures higher, which punished the already suffering cooler. One failure fed the next. The third domino was the particulate filter. Every diesel of that era carried one, a filter meant to trap soot and periodically burn it away in a process called regeneration. But the MaxxForce, choking on its own recirculated exhaust, produced soot faster than the filter could passively clean it. So the engine forced regeneration far more often than it should have, sometimes every few hundred miles, instead of every 800 to 1,000. During each of these events, the filter heated to extreme temperatures to torch the soot, and it drank fuel to do it, often close to a gallon at a time. Drivers watched their trucks lose power and belch black smoke for 20 or 30 minutes while the machine cleaned itself, time that was simply stolen from the working day. Some drivers learned to be careful where they parked during these cleanings. The exhaust could grow hot enough to scorch grass or ignite debris near the tailpipe, so they sought out empty pavement and waited, engine roaring, going nowhere. A truck is a tool for moving freight and earning miles. The MaxxForce too often was a tool for standing still, and the dominoes kept falling. The frequent regenerations and the extra fuel. Twice in 2011 and again in 2012, Navistar submitted its engines for full certification, and the agency refused to grant it. The engines could not clean up to the standard. Every other manufacturer had cleared the bar. Navistar kept coming back with a design that could not, no matter how many times its leaders insisted the finish line was near. Then the government closed in. Because the engines could not actually earn the full 2010 certification on their own, Navistar had been leaning on a set of workarounds to keep shipping. First, it burned through banked emissions credits. Then it relied on a program that let it pay a penalty for each engine that exceeded the limit. But that lifeline was challenged in court, and in June of 2012, a federal appeals court struck the rule down. The penalty per engine climbed from around $1,919 to $3,775. Navistar was now paying the government for the right to sell engines that still could not pass. And every month that passed grew more expensive. For the small operator, the man with one truck and one loan, it was catastrophic. Many had chosen International specifically because they trusted the promise that this engine would be simpler and cheaper to keep. Instead, they faced repair bills that could rival a monthly payment, and downtime they had no cushion to absorb. Inside Navistar, the engineers fought on, increasingly desperate. They redesigned the coolers with thicker walls and costlier metals. They revised the turbochargers. They rewrote the engine software again and again. And every fix seemed to solve one problem while quietly creating another. You cannot patch your way out of a law of thermodynamics. They were bailing water from a boat with a hole they had designed in themselves. And so we arrive at the question the whole story has been circling. Whose decision was this? For years, the failure was framed vaguely, as if the engine had simply let the company down, as if the engineers had missed something. That framing is not fair and it is not true. The people who built these engines were doing their best to deliver a target that leadership had promised the world before anyone knew it could be met. The decision to bet the company, to reject the safe road, to mock the competition and ship engines that could not pass, belonged at the top. It belonged to Daniel Ustian. The reckoning came quickly once it started. On a single day in July of 2012, when Navistar finally admitted it would abandon the recirculation-only strategy and switch to the very technology it had ridiculed, the stock dropped more than 15%. Credit agencies cut the company's rating. Within weeks, Ustian was gone, resigning that August after more than a decade rising through and then leaving the company. The story did not end at the exit door. Years later, the Securities and Exchange Commission would accuse Navistar and Ustian of running what it called a campaign of deception, misleading investors again and again into believing that certification was just around the corner when it was not. The company settled for $7.5 million. Ustian settled separately for $500,000. The gamble had become a fraud case. The human cost was heavier than any fine. Navistar cut its workforce and shut facilities. In 2013, it closed its truck plant in Garland, Texas, erasing about 900 jobs, moving the work to other plants as it scrambled to stop the bleeding. And the engine at the center of it all was quietly retired. By 2016, the MaxxForce name was gone from the heavy lineup, replaced by engines that used, of all things, the exact after-treatment technology Navistar had sworn it would never need. The fallout reshaped the company. Its share of the heavy truck market slid as customers fled to rivals with engines they could count on. The replacement that followed, an engine Navistar, built largely on its own and later named the A26, would carry both the lessons of this era and the skepticism of buyers who had already been burned once. So what is left of the fatal MaxxForce factory today? The engine is a memory, a cautionary tale traded among truckers and mechanics who lived through it. Navistar itself survived, but not as the independent American giant it once was. In 2021, the company was absorbed by Traton, the heavy vehicle arm of Volkswagen, the German parent that also owns MAN, the very firm whose engine architecture sat at the heart of the MaxxForce. An American icon that once hauled the freight of a nation now answers to owners across the ocean. There is a bitter symmetry in that. It would be easy to blame the regulators. Plenty of people still do. And the argument that the standards were punishing is not without merit. But the standards fell on everyone. Cummins met them. Detroit met them. Even Caterpillar, when it saw the wall, had the humility to step aside. Navistar alone bet its future on being right when the evidence was already telling it that it was wrong. That is the real lesson buried in all this steel and soot. The engine did not break Navistar. Physics did not break Navistar. What broke Navistar was the refusal, at the very top, to look at hard truth and change course while there was still time. Pride is a fine thing to build an engine with. It is a terrible thing to steer a company with. If you worked on these machines, drove one, or watched them come and go, tell your story below. Your memory is the history that never makes the headlines. And if the rise and fall of American industry is the kind of story that stays with you, stay with us. There are more of these giants and more of these lessons waiting to be told.